Let's start with a quote from Sidney Dekker from the Field Guide to Understanding Human Error. The point of a human error investigation is to understand why people's assessments and actions made sense at the time, given their context, and without knowledge of outcome, not to point out what they should have done instead. So in the last lesson, we traced the 5 whys from the factory floor at Toyota to its adoption across virtually every industry on Earth. We saw how a tool designed for diagnosing mechanical failures in deterministic systems was repurposed without much critical examination for investigating failures in complex human systems. So now we want to look at what that looks like in practice, not theory or abstract. So let's just walk through a realistic investigation scenario step by step and watch what happens. Watch how the method transforms, how it shifts from genuine problem solving into something that looks and feels like a prosecution. And most importantly, watch how natural it feels, because that's the real danger of the 5 whys when applied to human systems. It doesn't feel like it's going wrong. It feels like it's working. So let's set the scene. Imagine you work at a mid-sized technology company. You run a SaaS, software as a service platform, that your customers depend on 24 hours a day, 7 days a week. Last Tuesday night at 11:47 p.m., your platform went down, completely down, and customers could not log in. Data was inaccessible. For 2 hours and 14 minutes, your service was offline. By the time it was restored, your support team had received over 300 tickets. Your largest enterprise clients had scheduled a call with your VP of sales. The CEO wants answers. 2 days later, the team gathers for the postmortem. There are 8 people in the room: the engineering manager, 3 senior engineers, a DevOps lead, a product manager, a QA lead, and you, the director of operations, facilitating the investigation. Everyone has a laptop open. The timeline has been reconstructed, and you begin the 5 whys. Here's how it goes. Why number 1. Why did the platform go down? The answer comes quickly. A database migration script was executed in production that dropped a critical index table, causing cascading query failures across the platform. Okay, good, clear, technical. Okay, no one is uncomfortable yet. This feels like problem solving. We have identified the proximate cause. Now, why number 2? Why was a database migration script executed in production that dropped a critical table? Because an engineer ran the migration manually during a late-night maintenance window instead of using the automated deployment pipeline. Do you see what happened immediately already in step 2? We've moved from a technical event to a human decision. An engineer did something. The crosshairs have begun to move. Okay, why number 3? Why did the engineer run the migration manually instead of using the automated pipeline? Because the automated pipeline had been failing intermittently for 2 weeks, and the migration needed to be completed before the product launch deadline on Wednesday. Notice there are 2 critical pieces of information in that answer. The pipeline was broken, and there was a deadline pressure. But the 5 whys can only follow one thread. It's a linear tool. It can't branch. So let's see where we go with why number 4. Why did the engineer decide to bypass the broken pipeline instead of escalating the pipeline failure? The question shifted here. It's no longer about the system. We're asking, why did the engineer make this decision? We're asking about a person's judgment. Embedded in that question is the assumption that there was a correct choice and this person failed to make it. The engineer answers, because I had raised the pipeline issue in stand-up twice. It had not been prioritized, and the product manager told us the launch deadline was non-negotiable. I thought running it manually was the responsible thing to do. Okay, now why number 5? Why did the engineer think running an untested migration manually in production was the reasonable or responsible thing to do? Now that's not even a question. It's a verdict framed as inquiry. The outcome is predetermined. It's almost like asking, okay, why are you stupid? Excuse me? But because they can't do that in business, they say it like that. Why did the engineer think this was responsible with the untested, manually, in production? How could you possibly think that was responsible? That's not a question. It could have an answer, and it already was partially answered before, but all that's being ignored. So this verdict, this predetermined outcome has happened. The engineer says quietly, I should have pushed harder to delay the launch, and the investigation ends. But the root cause has not been found. Let's think about the story that we missed. A systems-oriented investigation would have uncovered a very different picture. The deployment pipeline had been failing for weeks and had not been prioritized. The maintenance window had no peer review requirement. The staging environment had drifted significantly from production. The launch deadline was set without engineering input, and there was no rollback capability for database migrations. These were latent conditions, at least 5 of them, any one of which, if addressed, could have prevented the outage. And the 5 whys didn't find any of those. It just found a person. It found a scapegoat. So we want to think about why this happens, because it's not a failure of intention. Everybody didn't go into that room intentionally planning to bury that engineer, hopefully. This is a structural feature of the 5 whys method. Social psychology describes the fundamental attribution error, the tendency to attribute outcomes to individual character rather than situational context. The 5 whys amplifies this bias. Each successive why narrows the focus further onto the individual. Sidney Dekker describes this with precision. Split-second operational decisions are later evaluated by people who are not present, with full knowledge of the outcome and unlimited time to judge them. Dekker calls this local rationality. People do what makes sense to them at the time given their goals, knowledge, constraints, and pressures. The engineer's decision was locally rational. Amy Edmondson's research on psychological safety shows what happens next. High-performing teams report more errors, not because they make more mistakes, but because they feel safe speaking up. Now, blame destroys that safety. James Reason distinguished between active failures and latent conditions. The 5 whys is structurally biased toward active failures, the person at the sharp end, while leaving latent conditions untouched. Todd Conklin summarizes it simply: workers do not cause failure, they trigger weaknesses already present in the system. Now, the real damage is what people learn. This is the cruelest part. They learn that raising concerns does not lead to fixes. They learn that initiative is punished when outcomes are bad, and they learn to stay silent. John Allspaw describes this dynamic clearly. An engineer who thinks they're going to be reprimanded is disincentivized from providing the details necessary to understand how the failure actually occurred. That lack of understanding guarantees recurrence. You notice in our example, nobody was really listening to that engineer before or after. A systems-oriented investigation would ask totally different questions. Not why did the engineer bypass the pipeline, but what made that action make sense at the time. Those questions map systems, not people. And Sidney Dekker said underneath every simple story about human error is a deeper story about the organization. The 5 whys gives you the simple story, and it gives you a way out from fixing the real problem. Preventing failure, though, requires the deeper story. In the next lesson, we're going to examine the science behind why this happens, linear causality, hindsight bias, and how language shapes investigation outcomes.